Hi, how's everyone doing today? Excited? Yeah. Animations. So, as some of you might know, how many people here listen to Stack Trace? So you know I love animations, right? Yeah. And we hold these devices in our hands these days, and much of the experience it's shaped by these animations. So it's important for animations and interactions to feel right to our users. So let's go back and remember this guy? How many of you had one of these? Fun times, right? So back with the original iPhone, we would press the home button several times to like enter multitasking or go to the app switcher or close the app. And then Apple came up with this. This is more familiar these days. So with iPhone 10, the interaction changed to direct manipulation of the contents on screen. So people think about these interaction as, oh, I just flick up and I close the app. How I think about this interaction is I tap an icon, the app comes from the icon, and then I throw the app back into its icon to close it. So it's a much more natural way of doing things. And in case you don't know, this is how it works. So you just send the app back to where it came from. So this type of interaction works. I think most people agree that this is good, except for maybe this guy. Yeah. But, well, let's not talk about him. So it's easy to look at something like this and think, well, okay, but this is Apple. They have magic pixie dust they use in their code that I don't have access to. But I think these effects are achievable, even for us. I don't know, some of you might be independent developers, work at a small company. I work at a medium company, but I'm also an indie developer. And even for us, this is achievable. It can be a little bit tricky, and that's why I'm giving this talk, and I'm also going to give you some open source code you can look at. But before diving into some code, let's see what makes an interaction feel fluid to the user. And I said the word feel, and you're going to hear this word again probably during this talk. Much of the work that goes into these interactions is about making things feel just right. So when you're going to find yourself, when you're developing these interactions and animations, playing around with your app in your hand. So you're going to be throwing things around on the screen. And that's usually a sign that you got it right when you start like playing around with it and it's 10 minutes past and you're still playing with it. That's usually when you got it right. It feels right. So let's take an example. I have this app and it has a toolbar. And I want this toolbar to be movable. I want to be able to move it from one side of the screen to the other, because some people, they might be left-handed or right-handed. They prefer it on either side. So the obvious answer is let's just add a preference. So the app has a preference screen, and I could just put it right there, right? Easy peasy, just a user defaults key, and then you're done. Well, but that's not very good. Like, I'm here working on my latest chibi, and I have to go into the settings to change the toolbar. Maybe I want to do it more than once, several times, because I'm moving things around a lot. So that's not very good. So let's implement direct manipulation. So I think this is the best approach in this case. So the user can move the toolbar with their finger. There's a little grabber thing at the top that indicates this is movable. But as you can see from this video, there are a few things that aren't quite right. Like, I could definitely ship this as is. It's good, like, it works, and it's way better than a preference. But when I move it, I want to, like, throw it to the other side and have it stick to the other side. And I want it to have some bounce to it, some momentum, some physics. So let's change the animation curve from the easy and out one I use here to a more complex, more fluid, composed curve. So let's do a direct manipulation and a bouncy animation. So with this, it's a little bit better. Like when I throw it with more force, it goes forward a little bit more. But there's still a problem that the logic I'm using to decide which side of the screen it should land on is based on where I lifted my finger. So if I move it past the half point on the screen and lift my finger, it's going to go to that side or the other side. But I really want to be able to just flick it to one side or the other. And to achieve that, we have to use something called projection. So instead of just using a binary, is this more to this side or the other side when I lift my finger, I'm actually going to look at the velocity of my gesture and the direction it's going in to decide where it should go. And what projection is we're going to, and I'm going to show you some code later, don't worry. Projection is we're going to project where this would land if the user kept going. Like we're going to pretend like this input I'm giving is infinite. So where would this land with this velocity and the deceleration rate? And with that, we achieve this result here, which I think is way better. So I can just throw it with force. If I don't throw it with enough force, it's not going to go to the other side. And it's also going to follow my velocity. So if I throw it really hard, it's going to bounce more. So this feels right to me. So I've given you an example of how we can take something from no interaction, no direct manipulation at all, to something that feels more fluid to the user. But it's important now that I explain to you some concepts about animation. Most of you probably know about these, or at least some of these, but I think it's fair to give a refresher. So the simplest form of animation is the linear one, which is boring. Don't do this. So things in real life, they don't start at their full speed and then stop dead at the end. They have acceleration. So linear is boring. Like it usually looks brittle. It's not very nice. So one that you're probably more familiar with even is the easy in out curve, which is way nicer. So there's some acceleration and deceleration. It starts slow, speeds up, then slows down as it reaches the end. So this gives the animation a much more natural feel, and it's way better. But there's something that's even better, a spring animation. We all love spring animations. They bounce all around, right? But there's something about spring animations that you need to be aware of. They don't have to be bouncy, necessarily. Spring animations, we think about them usually as like, oh, it bounces all around, but you can tune your springs in a way that they don't bounce too much, but they still give a little bit of bounce, but very little. Like this example, there's very little bounce, but it's enough that it looks more natural. But my favorite is the composed one. So what a composed timing curve is you combine a cubic interpolation method with the spring. So you start your animation as like an ease in this example, and it transitions to a spring when it reaches the end. So as you can see here, when I start the animation, it starts a little bit more quickly than before, but in the end, we still have that little bit of bounce from the spring. And you can do this quite easily on iOS. Don't copy this code. It's all public. It's going to be on my GitHub. Don't worry. So you can implement the UI timing curve provider protocol. And for the timing curve type, you return composed. And then you return cubic timing parameters, which can be easy in, easy out, whatever you want. And also spring timing parameters. So you can have a combination of both. And then you can feed this into a UI view property animator, like I've done here. So yeah, you create an instance of this custom timing provider, you feed it to a property animator, and add your animations. By the way, notice how the duration here is 0. This is important. If you're dealing with spring animations, setting a duration doesn't really make sense because the spring has its own properties that are going to define how long the animation should be. You can think of it as kind of like a physics simulation, even though it's not a real physics simulation, but it has its own timing baked in. So you can initialize a property animator with duration of 0, and it's going to just use the spring to define the duration. And you can actually read the duration property, and it's going to tell you how long it should be, which can be very handy in view controller transitions. So the projection thing I talked about, this is the code I'm using. So basically, you give it the velocity and a deceleration rates and use this complicated math that I don't understand to project and notice how this is done for a single point. So it's not CG point, it's CG float. So usually most interactions and animations, they work in one specific axis, either the Y or the X axis. So you can, most of the time, you can just ignore one of them. And this is code that I took from a playground I'm going to make available for you. And this is how I project the target position based on the current position of the object, a specific velocity. And as you can see there, I'm taking which axis has the velocity that's greatest than the other one, and I'm using like the dominant axis of motion to determine the velocity. And also notice how I'm using this. This is the normal deceleration rate for UI scroll view, which is available as a public API. So if you base your animations, your projection using this deceleration rate, it has a tendency to feel more natural to iOS users because it's the same deceleration rate that you get with UI scroll view when you flick it up to scroll or down. So let's see some tips and tricks that I think can improve your animations. If you have some animations you want to improve in your work. And the first thing that must be done is to choose the right technique, because iOS gives us lots of techniques. I'm not going to even talk about all of them here, just the major ones. And I'm sure all of you know this. Raise your hand if you don't know about this. No one, I think. OK, good. So I think you're the right public for this talk. So this is the most common one. It's simple. It's easy. It gets the job done. There are places where this can be used. If you want to just animate something, there's no user interaction involved. It's just a simple, informative animation. But my favorite one is UI View Property Animator. And I know it can be scary. It can crash sometimes if you don't do it just right, so be careful. And the best thing about it is that you can use UI View Property Animator to integrate it into UI View controller transitions. So you can implement beautiful custom UI View controller transitions, and you just return a property animator from one of the methods, and it does all the work. So it's really nice, and it has the other properties, no pun intended, that you can pause the animation, you can progress the animation manually. So it's really, really nice for custom interactions. And now I'm going to talk about springs. As you can tell, I'm a fan of springs. Christian wrote a really good piece. It's called the Mystifying UI Kit Spring Animations. The link is going to be available on my GitHub. So he talks about how the springs, the way we define springs on iOS is not very designer-friendly. So he proposes that we define springs using damping ratio and frequency response, just these two properties. And he shared some math, again, that I don't understand, that does the calculation based on these two properties. And just by tuning these two properties, you can get really nice spring animations. So another technique I'm going to briefly talk about is Core Animation Archives, another thing I'm a fan of. So I have this blog post about it, and I also gave a talk at AltConf about Core Animation Archives, so you don't, I'm not going to go into detail here. But if you have an animation that could be a video, like this onboarding I made, this could be like a video file, but if you do it using Core Animation Archives, you can have it be a vector. And that's really good since we have all of these different devices. So basically what you do is you encode a CA layer tree to a file, and it can have animations, and then you load it at runtime. And you can use a tool like Kite Composer to create the animations, which is what I've done here. So keep that in mind. If your animation has many elements, like it's the case here with the top there, maybe using another technique could be better. Another thing that made me do better animations, I feel like, is thinking backwards. So I think one animation that's very common is a view controller transition. So it's common for you to think about it like this. Oh, I want this to fly from here and grow. But the way I like to think about animations is thinking about the end state. Think about how it's going to end. So in this example, I have this custom transition I made. And I developed this animation based on the end state, which is this one, with the editor opened. And then I thought about which transforms do I need to use to move things to where I need them to come from, and that sort of stuff. So think about animations based on their end state, not based on how they're going to start and where things are going to come from. And set up your code like that. Set up the end state, and then work backwards to the beginning state. I find that this has saved me a lot of time and trouble messing with animations. Another thing that can be fun is to integrate the device's corner radius into your animation. So we have the new devices that some people like and some don't, like I showed you. And they have a rounded screen. The corners are rounded. So a fun thing you can do if you have elements that come from the bottom or the top, or they fill the whole screen, you can use the screen corner radius. Like this custom sheet implementation I made, you can see that as it's dragged, the top there, it starts with the device's corner radius, and then it shrinks to the final corner radius. And then at the bottom, when it bounces, it also follows the device's corner radius, which is similar to how the standard one on iOS 13 looks like. So this was done also to make it feel more natural and more connected to the actual hardware, which is kind of cool. And there's no public API for screen corner radius, unfortunately. I have a feedback or radar or whatever it's called these days. But you can use this lookup table, which I compiled for you. I think those are all the different corner radii. So yeah, just use that as like a lookup table. There is public API to get the device model, so you can figure that out. It's not very hard. Or you can use value for key, but don't. So there's this thing called UI interaction, and I really like it because this code that deals with interactions and animations can get quite messy sometimes. It's inherently stateful, so you're managing all of these things moving around, and you have to keep track of progress and stuff like that. And we have this really neat protocol called UI interaction that we can use to encapsulate the logic involved in a complex interaction. So this is the protocol. It's available since iOS 11, but you could make your own one if you want backwards compatibility. There's nothing special about it. It's just it gets a view, and it has callbacks for will move and did move to view, and that's where you can hook, like add your gesture recognizers and stuff. And that toolbar I showed you, that's how I made it. It's a docking interaction, and it's initialized with the docking stations. So those are views that I position using auto layout, and also an initial docking station. And then I just add the interaction to the toolbar controller's view, and that's it. So from the point of view of using this interaction in my view controller, it's very simple, but the actual interaction is a little bit more complicated, but it's neatly hidden behind this custom UI interaction protocol and this docking interaction I made. Also, very important, keep your animations short. It's very easy to get carried away with making all these cool animations. You want people to see your animations. You spend hours making them. So you make them like 5 seconds long or something. Don't do that. People don't like that. So I want to get my work done, and then I have to like wait for an animation to finish. That's not cool. So, and another thing you must do as well, which I think is important, is make sure your UI stays responsive during animations. And if you can go the extra mile and actually implement interruptible animations and interactive animations, that's even better. Like, if you can try this out if you have one of the iPhones with no home button. If you tap an app, you can flick it back to its icon before it's finished launching. You have to be fast because it's a fast animation, but you can just like tap an app and close it right away. So you don't have to wait for the app to finish launching until you can close it back up. Let's say you launched the wrong app, you can just tap it and flick it back to the home screen quickly if you made a mistake. So keeping your animations short and making sure that you can still interact with your app during animations is also very important. So let's recap what we went through. Fluid interactions and animations, they just feel right. So it's very important for you to take your device in your hand and play around with what you're making. This is the best way. There's no automated testing or QA process that's going to make sure your animations are natural and fluid. So make sure you are developing and iterating quickly. And if you can't iterate quickly because of some technical detail in your project, maybe create a separate prototype project and then bring that back to your project later. So make sure you are able to feel the animations in your hand. Use that custom timing provider with a compose curve if you're going to do an interactive animation that will yield the best results for you. Make sure you are using the best technique for your use case, using UIView.animate for simple stuff, UIView property animator for interactive things, core animation archives for decorative or informative content, and even videos depending on the use case. Think backwards, start from the end state of your animation, and then go to the previous state. And also use UI interaction to manage the complexity of your animation code. So the best part about my talk, I didn't show you that much code. I think it was light in terms of code. But I do have a neat iPad playground you can play with. As soon as I'm off stage, I'm going to log into GitHub and open source that repo. So you're going to be able to find it on my GitHub. And there are also some links in the README that you should check out, including one for that custom sheet implementation I showed you. That's also open source. So you can see how it's done in practice. And that's it. Thank you.
All right, so we're going to follow the same flow, 3 questions. Just raise your hand, and you'll be given a mic. And come on, don't be shy. That's it. We got a question there.
Hi. Do you have any special considerations for when you're doing an interactive animation and you don't know where the user might interrupt it or go backward? Like, do you think that just focusing on the end state and the first state will be enough to always achieve something like pleasing to the user? Or do you think that do you have to have anything else in mind for those cases?
Oh, you have to have lots of things in mind. That's a great question. Yeah, so that's like the first step, to think about the end state and then develop it backwards to the beginning state. But the tricky part is what's in between, right? What happens in between? So for that, there's no magic. Like you really have to think about all the edge cases, like what if they open Control Center while they're in the middle of the animation? How do you decide whether to cancel the animation or move it to its end state? That's why I talk about feel so much, because it really is something that there can't be like a rule. You have to feel it in your hand and try it and, oh, this didn't feel right. And sometimes you have to show it to other people as well. I find that can be useful. But that's why we need something like UI interaction, because all of those edge cases add up, and you end up with some messy code if you're not careful. Thank you for the question.
Another question? There we have one.
Where can I learn about iOS advanced animations? Do you know some website, blog, or something like that?
Yeah, so I'm gonna publish on my GitHub the repository I made. It has a playground that has an example showing how to do the projection thing, and also has a link to that demystifying UIKit animations I talked about, which is a great article and a great starting point. There's also a YouTube channel called Coding Math, which talks about the math behind like easing out, these types of things. And even though we don't use that in our daily jobs, like UIKit does the easing for us, I learned a lot by like following the tutorials and actually creating my own easing out curves and things like that, because you start to understand how it actually works under the hood, and I find that it helps you in the end. Even if you don't quite understand the math, which is my case, you will find that knowing what's going on behind the scenes and knowing that it's not magic, it's just like code, it helps a lot. So definitely check out those resources and shoot me a tweet if you have any questions. And if anyone has any other questions, they can find me later as well.
Okay, we have time for one more question.
Awesome.
Oh, yeah, I like the attitude that way.
Hello, this is Rafael from Brazil. By the way, great talk.
Obrigado.
My question is regarding unit testing or UI testing. Is it a challenge to test those kind of complex animations? And
Yeah, it is. Yeah, that's why I talk about the feeling it in your hand. It's very hard to test this stuff because it is so random in a sense. Like, you can flick something more to the top or to the bottom or to some on the other side or with certain velocity. So I think at most, like, you can make sure the animation happens and that nothing ends up in a bad state, like something is not interactable after an animation. You can make sure it doesn't crash during an animation. That's also something you can test automatically most times. But yeah, automatically testing animations, I think someone needs to come up with something for that. I don't think we're quite there yet. We have screenshot testing. Maybe we need like screencast testing, like an AI that watches the video or something. But yeah, there's no way to automatically test.
Okay, thank you very much, Guy. A big clap.
Thank you.